There we go. Okay, hello everyone. I really appreciate you being here today. I really appreciate everybody online who's watching this as well. And I'm really excited today to be here at the SANS PenTest HackFest 2022 Summit. It's an honor for me to be on this stage, sharing it with so many talented InfoSec professionals, both yesterday and of course today, both on the red track in the other room and here in the purple track. So my topic today, well, actually, I will say that I'm especially kind of excited to be here on the purple track because, in my opinion, the future is purple. That doesn't mean you get rid of the red and the blue, but I think that the future methodology is purple. So my topic today is on crafting adversarial detections at scale in Google Cloud Platform. And I'm actually going to open this with a short story. It's a true story. And I actually had a different story that I wanted to open with. I have prepared that one. I've read through it like many times. I practiced it. But I think Ed Skoda said in his keynote this morning, there's certain places that you have a eureka moment. And I think his was like Olive Garden. And those breadsticks are great, you know, but mine is driving in my car. And I was taking the trip down here from Pittsburgh. And I'm like, I hate that intro story. I'm going to trash that. I'm just going to write a new one in my hotel room. And that's what I did. So, you know, it's short. But last year, a question. Who here has ever been denied budget for some security tooling? Right? Yeah. So let's not lie. Like all of us, please. All of us have been denied budget for security tooling. And we've been there, and it's not because the tools aren't good, it's because they're expensive. So last year at Gatsby, I wanted to start working on our detection engineering program, and I got a lot of the high profile tasks out of the way, and I wanted to level things up. So I do like to build things. That's why I'm here today, because I like to build things. But purchasing is the more efficient route sometimes, and we're running a business. So we have to be efficient. So I took a lay of the land, started some vendor discussions, and you know how these things go. You want to quote. Like first meeting, be like, please just tell me how much this is. But you go through a few meetings and the song and dance and stuff. And I must say, there are some really nice commercial detection monitoring tools on the market. But inevitably, we got to the discussion about price. And at that moment in time, it was just too high for us as a business to justify it. So I did, try that Hail Mary pass. And I wrote up the proposal anyways to the executive team. But, when we discussed it, everybody saw the merit. The executive team saw the merit. They understood like why we need these tools. But, Gatsby is a startup, and we have to make decisions on how we allocate our resources. That means I in security don't get everything I want all the time. This means other people don't get everything they want all the time. So what I did, I don't like settling. So I shifted my pitch and I said, okay, we won't buy commercial tools right now, but in a future quarter, I'm going to budget time. And I want that time to explore writing our own detection engineering tool set. And we're going to do that with some open source tools and some of our functionality already at our disposal in Google Cloud Platform that we just aren't tapping into at that moment. So I figured the bonus of this was that I got to put a talk together, like a SANS talk, and submit it to a conference, and it was luckily accepted, which is why I'm here today. So, okay. Today, we will cover how to build a comprehensive detection engineering toolset in Google Cloud Platform that also monitors Google Kubernetes engine workloads and these workloads that are under very heavy continuous use, and do this all essentially for free. So, who am I? Quick background on who I am. I'm Mike Gualtieri. I've been in software and cybersecurity for more than 20 years, wearing both business and technical hats, usually both at the same time, which is cool. I like being in that space. Last year, I decided to take on the role as the first dedicated security hire at the high growth startup Gatsby, where I lead the security and compliance program for the company. And we've accomplished a ton in the last year and a half, I have to say. We went from no formal security program to SOC 2 Type 2 compliance in under a year. We started vulnerability management programs, incident response detection engineering programs with quarterly simulations of both those things. We conduct internal penetration testing now. And of course, today's topic, detection and response program. So if you want to know what I do on a daily basis, just go to gatsbyjs.com/security. I wrote all the text on that page, so it's from me. In addition to my role at Gatsby, I'm on the part-time faculty at the University of Pittsburgh School of Computing and Information. And for them, I developed 2 courses in cybersecurity that I sometimes teach. It's the Offensive Boot Camps 1 and 2 that teach students about vulnerability exploitation and penetration testing. And prior to Gatsby, I spent 15 years as an entrepreneur leading cybersecurity and software development projects for dozens of companies as a consultant. And I founded a startup before that, but the startup didn't go well. So that's how I ended up consulting. So the consulting went well. Okay. So what is Gatsby? So if you aren't familiar with Gatsby, you might be wondering, what is Gatsby? What do we do? And I promise this is not an advertisement. It's core to our conversation today, because our business at Gatsby is remote code execution as a business. So it's pretty crazy, right? That's a crazy business to be in. But that's the business you're in if you automate software development for companies. And that's the business many CI/CD pipeline companies are in. So Gatsby itself is an open source React-based framework that lets you build websites. We're known as being a so-called static site generator, but we also have dynamic functionality like serverless functions and server-side rendering. So as this diagram represents, as a Gatsby customer, what you do, you take your Gatsby website source code and you put that into your version control system. And that's piped into the Gatsby cloud. And in addition, you pipe in your data sources and content sources. So things like a headless CMS, some data API, all that's put together in Gatsby cloud, and Gatsby inside that cloud will compile it essentially. It's essentially like a web compiler. And what it generates is highly optimized HTML, JavaScript, CSS, images, and those are all then deployed out to a global CDN edge network. So pretty cool, right? I think it's cool. And we have some amazingly talented engineers on our staff that make all this stuff work. And I really do feel that the future of web application development is heading towards this more headless and more static mindset. One big reason is these so-called Jamstack websites are actually a boon to security because they greatly reduce a lot of the OWASP attack surface that a traditional website architecture would have. But I'd love to talk about that. I have talked about that, but that's not what we're going to talk about today at all, because today we're going to talk about how to protect a cloud infrastructure like the one we have at Gatsby and detect potential attacks in there in an environment when you allow everybody in the world to execute remote code on your server. So this slide illustrates a high-level view of how our Gatsby cloud infrastructure is designed. If an HTTP request comes in and can't be served as a simple cache hit at the CDN layer, requests come into our GCP infrastructure, and it first hits something, a service we call router. And router determines how best to serve up that request in our infrastructure. Typically, it's going to end up going to one of our Kubernetes clusters, specifically one of our untrusted Kubernetes clusters. Or if it can't be served there, it's simply served up as a static asset that's already in our Google Cloud Storage. So to give you an idea at the scale we operate at, on average, the Gatsby cloud serves up about 3,200 to 3,600 requests per second. So that's HTTP requests per second. So that's pretty decent. And I will say that we have peaks at much, much higher than that, and sometimes lower, but that's the average. On a typical rolling 30-day average, we store about 8 terabytes of log data from our microservices. And that's, again, it's just our microservices application and just the log data we're retaining. If you're looking at the raw output, there's a lot of junk that we don't end up piping into Google Log Storage. But and it also doesn't count our HTTP logs. So traffic logs and all that are separate, not what we're going to discuss today. So Gatsby is not unique in this type of application architecture. In fact, this type of microservices cloud architecture is becoming more and more commonplace. Now, on this slide, I pulled several tear quotes from recent Palo Alto and Unit 42 security and threat reports. So, you know, you could read through these while I'm talking, but there's nothing surprising here, but I do like to back up my claims with authoritative sources. So the quotes on the left indicate that cloud and containerized workloads are rapidly growing. And on the right, where organizations go, threat actors, of course, follow. So most of the threats right now, there's 5 specific threats that Unit 42 tracks, and they're specific to cloud, that is. And the most prominent of this being Team TNT. And most of the groups in this space right now, they are typically crypto miners, right? They like to steal resources from you. But that doesn't mean that just because they like to deploy crypto miners that they aren't harmful. Each of these adversaries have been known to deeper probe cloud environments, and upon initial access, they like to probe the system for their permissions and expand the scope of their access. And of course, with additional discovered resources comes additional compromise. And when there's additional compromise, there's credential theft along the way. So it becomes a big mess. Some of the more advanced groups in this space have demonstrated the ability to escape containers and evade workload security monitoring tools, especially by moving from the workload environments over to the cloud environments that control these workloads. So I would not say it is a stretch to predict that as cloud adoption continues to grow, as architectures like the one we have at Gatsby continue to become more and more commonplace, and the juicy data moves from the corporate networks into the cloud, that we will see more and more dangerous threat actors with better capabilities in the future. And this was my talking points for the slide, but yesterday, at Dave Kennedy's keynote, he mentioned lapsus. Lapsus is a more dangerous threat. They're essentially, I think, like groups of teenagers in the UK and I think in South America that have made a real mess out of some corporate networks. You know, they've had high-profile breaches like Microsoft, and they've gotten into these networks through the cloud portions of these organizations. So it is starting to scale up. All right. So our task is to secure the network, all right? And we should just start writing detection rules day one, right? No, I don't like that at all. In my humble opinion, actually, no, I'm gonna make it in my non-humble opinion, prevention should lead detection. Penetration testing should happen before detection. The reason being, and actually Bryson mentioned this in his talk right before mine about understanding your attack surface. That's my point here, is that you don't know what you're protecting. You need to know what you're protecting before you can detect anything. And the only way you're going to know what you're protecting is to understand that attack surface. And the only way to know what that attack surface is to do comprehensive internal and external penetration testing. So the first thing you should aim to detect is what happened in your last pen test, if the attacks worked or they didn't work. In fact, a professionally written penetration testing report should document the tools and methodology used along with any significant command output. There's your adversarial emulation plan, right? Pen test report, a good written pen test report makes an excellent adversarial emulation plan. And we'll look at that a bit more at the end of this presentation. So let's get into this a bit. There's 2 pieces into gaining full visibility into a cloud microservices application architecture, and that is workload and cloud. So workloads are the environments, the pods, the containers, the microservices that make the application work. Cloud is the infrastructure as a service used to glue everything together. So cloud, I'm talking about IAM rules, users, service accounts, serverless functions, cloud storage, cloud build, cloud SQL, et cetera, et cetera, et cetera. And the list just keeps on growing. Workload is going to mostly be where a breach is going to originate, but that's not necessarily always the case. For example, an adversary might be able to fish for IAM credentials in a two-factor auth token and end up right on your cloud environment. Or maybe a supply chain attack led to the leaking of API keys or authentication token, providing a direct means to manipulate cloud resources. But for the most part, the workload runs the application, and it's what your users interact with. And vulnerabilities in your application will provide a direct means for an adversary to start manipulating those workloads. Detection at the workload level is mostly executable oriented. And by this, I mean certain commands and processes executed in an environment. And they may be called by known parent processes and known environments, or not, because execution of these are anomalous. Detection in the cloud is mostly event-oriented, that this service account took an action that is atypical. For detection within workloads, we'll turn to a powerful open source tool known as Falco that I'm hoping that maybe some of you out there are maybe familiar with already. For detection in the cloud, we'll turn to GCP log-based alerts, a powerful and essentially free tool at our disposal. So the question is, what to detect and where? Emulating adversaries is more than running random commands. It means understanding your attack surface and the TTPs, the tactics, techniques, and procedures that can be abused in these specific areas. I actually did a full talk on the topic of conducting an assumed breach penetration test at a cloud native organization last year at the Adversary Village at the Texas Cyber Summit. So give it a watch if you're interested in digging deeper on scoping and conducting such a penetration test. But one of my big takeaways from that talk was how to map the attack surface for cloud infrastructure and how doing a pen test on an assumed breach specifically is different in a cloud environment than a traditional corporate network. So this slide shows some examples of what's possible at each key location in an infrastructure like ours. In your workloads, you need to be on the lookout for commands that would be involved with gathering information about your environment. So that would be situational awareness. You need to look out for loading tools that could be useful in an attack. That's bring your own tools. You need to look at atypical use of programming language interpreters. That would be coding your own tools. Anomalous network connections, pay attention to those. And especially look at attacks that are aimed at breaching that workload cloud security boundary. Untrusted environments can and should have a more lenient rule set than trusted environments, of course, but carving out big exceptions because a default rule is noisy is not a good idea. Try to make your exceptions as specific as possible, ideally targeted to a specific microservice. It may take longer to whittle down false positives when you're doing this way, but the result ends up being much tighter and much more effective because you're modeling the rule set against your specific application's behavior. In a cloud environment, you should be able to alert on events that result in modification to key resources that don't change too often. So think things like IAM permission changes. They do change, but usually it's through change control, right? They shouldn't just randomly change. Also, detect on the listing of resources and of course, permission denied events. And these last 2 points are really key to what we're going to discuss today in the cloud piece. Remember, an adversary knows nothing about your environment day one, maybe a little bit through some OSINT, but not how you know it. They're much more inclined to list resources and probe services, resulting in, of course, permission denied errors, hopefully. It's very atypical to see a service account listing resources. A service account already knows what it needs. It's going to get what it needs, right? It's not going to list anything. Catching potential enumeration in your environment is the key to discovering adversarial behavior at early stages of the attack lifecycle. Well, as usual with my talks, I like to make them practical, and I always like to give away some free goodies. So at the bottom of this slide, there's a URL. And if you go to that, you'll be able to access some of the resources that I'll discuss today. And of course, special thanks to my boss, Dustin, the VP of Engineering at Gatsby, who's allowing me to give away some of what I did, some of my work away for free to you. So let's start the discussion today about building high fidelity alerts in Google Cloud Platform. And high fidelity to me means alerts that don't trigger too often and cover realistic portions of the attack lifecycle that may take place in your environment. That's key. GCP has 2 main sets of logs that provide the majority of the intelligence that we can use today. And that is the admin activity log and the data access logs. Admin activity logs are on by default and capture user API modification to resources. Data access logs need to be enabled individually for each service and essentially track read-write API events for the target service. Care needs to be taken when enabling data access logs, because not all of them are going to be useful for you. And there's dozens. Just don't go there and just start checking off every box. Please don't do that. If you don't use a service and you don't think the service would be useful to an attacker to conduct some type of attack in the attack lifecycle, then don't enable logs for this. And if you widely use a service, use caution before you enable data access logs, because you're going to drown in logs and it's just not going to be useful for you. And if you're drowning in logs, you're of course drowning in the cost of maintaining those logs, which is not super cheap. So some of the rules that we'll discuss today also will involve firewall egress rules, and those are extremely useful as well. And there's another type of log that Google maintains. It's called the system events log that monitors Google specific activities. But for the purposes of this discussion, those logs really aren't useful at all to us. Honorable mention, I should say, is Google Security Command Center. And you should enable it, but just know that its free offering is a bit limited in usefulness. It does provide some beneficial findings, like the findings are tied to CIS controls, so that's good. And it's going to report things like if a bucket becomes public all of a sudden, or if a new public IP address comes live in your environment. Those are useful things to know. That's why you should enable it, monitor the findings. But for our discussion today, I wouldn't say they're going to be extremely useful. So configuring log-based alerts is actually pretty simple if you're familiar with the syntax of Google Log Explorer, which, by the way, is not extremely simple. But once you get the hang of it, it's actually not too bad. All right, so that's the hurdle there. But essentially, you need to create a log that pulls in the specific results you want to trigger an alert for. You don't want too many events being pulled in, because then the alerts just become meaningless. So it's important to tune these a bit for your business. But be aware, if you just day one enable the data access log, it's going to take a bit of time for those results to kind of start pouring in to even determine if it's going to create a useful alert for you. So you have to observe this. But once you're happy with the result and the frequency of those results, you can create an alert. It's really simple. I have it, the process laid out on this slide. That alert can then be also sent to a Slack channel that you monitor or a service like PagerDuty. So let's take a look at one of these in action. So this slide shows an alert event that was triggered for a service account listing secrets from GCP Secret Manager. Again, this is an atypical event. Outside of a few developers who have access to Secret Manager, this event should never trigger, right? But once the event is triggered, it can be reviewed. An incident is automatically opened by Google. You can review that, you can close it, you can acknowledge it, you can provide annotations, and once you're happy, close it out. And all those alerts are then sent to a Slack channel. This is my Slack channel that I monitor right here, and this is the alert that was generated. So what do we do at Gatsby? And the question is, what is an adversary going to do after they get access? And really, that's something you have to ask yourself. But once you get comfortable using Google Log Explorer, you can come up with your own alerts that are turned to your use case. But to get you started, on this slide, I have 16 alerts presented that we do use daily at Gatsby. And I think that the majority of these, if not all of them, are generally useful for most companies. And they also cover various parts of the attack lifecycle. So you can get all these, again, at the link at the bottom of this slide. So I'm not going to cover these in detail. Take a look at them. I'm happy to answer questions about them. But the one thing to know about these alerts is that they do fire during normal business activity. And that is totally okay as long as they don't fire too often. So remember, an adversary will likely try to access the same resources that your cloud engineers do. But if some of these alerts are noisy, simply filter out known employees or service account activity from them. But just be careful not to filter too much. I want to stress, your goal is not 0 false positives. It's not 0 alerts. It's adversarial detection. So there's going to be some legitimate noise that's going to always come through on that. Another useful resource that I just recently discovered is this GCP mind map for investigations and incidents. And I also list that at the bottom of the slide. It's by the company called Expel. And again, this resource shows various GCP services and API calls and how they can be beneficial to adversaries at various parts of the attack lifecycle. So you can look at that, see what might be useful in your environment. You extend my rule set from that. So it's just a great resource. So I highly recommend it. Okay, that pretty much covers our discussion about cloud. So let's turn our attention to workload, which in my opinion is actually a bit more fun. As I mentioned earlier, for workload detection, we're going to use an awesome open source tool called Falco. Falco was originally created by the company Sysdig, which is now, and it's now being handled by the Cloud Native Computing Foundation Incubator. Falco is typically used for Kubernetes environments for detection, but it can also be just used on any Linux OS for monitoring. Most people here, I think, probably are more familiar with Windows and Active Directory networks. So think about Falco as kind of like Sysmon, but just for Kubernetes. But Falco works by running on each node in a Kubernetes cluster as a pod. And that Falco pod intercepts syscalls that are happening on the node. And those syscalls can be happening in all the other pods and environments running on that node. It runs those syscalls against a tuned rule set that is to monitor for adversarial behavior. When a rule is violated, output is sent to standard out from the pod, and then it's picked up simply by Google Log Explorer. So this slide shows an example of a pod executing the command ID minus U. So if you aren't familiar with what ID is a very useful command. It's on every single Linux environment, and it allows an adversary to understand the permissions of their current shell. So that's useful. The log query here shows also how to filter out strings in Log Explorer. And I have that on there on purpose because filtering out in Log Explorer is extremely important for filtering out false positives, because a Falco vanilla deployment may trigger thousands of alerts each minute. So you need to tune, you need to filter and tune. So the strategy I recommend is to first filter things out with Google Log Explorer, extend that filter to your Falco rule set to remove the false positive, redeploy, rinse, repeat. Keep doing that until you're happy with the result. Again, it's your result's not 0 logs, or zero events. It's a reduced set of events that you can handle. So Falco comes with a pretty powerful default rule set, which can be extended with, of course, a custom rule set overlay. That rule set overlay can be useful in filtering out false positives and to tune rules specific for your environment. So if you visit the link at the bottom of this slide, I have available a Falco starter configuration that's already tuned for use in Google Kubernetes engine and can also be used with the tool Customize instead of Helm if you want to deploy that way. So the rule set also comes with a few new rules that I think are helpful. It's at least helpful for us. Specifically, rules for detecting calls to the GCP metadata API, coin miner activity rules, suspicious executable rules, and of course, access attempts to var run secrets Kubernetes IO and etc password. Now, when you're tuning Falco, roll things out slowly, one cluster at a time, eliminating false positives along the way. And I highly recommend to do staging, which is a more predictable environment, before production, which is, of course, unpredictable because you actually have users using production and they do unpredictable things. Now, I will say that if you're starting with my rule set, that the suspicious executables rule and the rules that detect on var run secrets, Kubernetes IO, and etc password are a little noisy out the gate. It's going to produce some false positives for you. But after some tuning, I think these rules specifically are really useful because it's very likely that an adversary is going to be living off the land in a very feature-rich Kubernetes environment with like Linux commands all over the place. And it's also very likely at some point they're going to try to access Kubernetes secrets and Kubernetes tokens. So these rules will help tip off that behavior once tuned properly. So to date, once we got our Falco environment up and running, we've been able to bust several cryptocurrency miners abusing our infrastructure. And let me tell you, it is wonderful to hit that ban button and get them out of there. And we've also been able to bust one legit attacker who was conducting Kubernetes style attacks in our environment. More on that in a minute. So let's see how our tools fare at detecting an attack. So this is the adversarial emulation portion of the talk. And this first emulation plan is designed to execute like a generic cryptocurrency miner. And I know this specifically because when we busted crypto miners in our infrastructure, I decided, let's take a little peek at the Git repos that they're trying to pull down. So I took those and I looked them for analysis, and our fake miner script won't actually do any harm, of course. And it's not going to do anything like spike the CPU up. That's not really the type of behavior I'm concerned about trying to capture, at least at this portion of our infrastructure. But what it will do is emulate the setup and execution of a miner script. So I broke it down in 4 kind of simpler steps, but essentially the miner repo is first cloned into the environment from GitHub. Next, it's going to unpack itself. And then there's a script that executes kind of the actual miner binary, which was hosted in that Git repo that's pulled down. So from there, it executes and is going to make out calls to or across the internet to known, or if you prefer, unknown crypto miner domains. To the execution of this plan, Falco observes 4 events in our environment and one cloud alert. And that cloud alert is a blacklist, the firewall blacklist event from the crypto miner domain being blocked at the firewall. So that's pretty good. That would get my attention and allow me to quickly drill down, diagnose the problem customer, and boot them from our infra. So let's look at something a little more interesting. And I promise, don't squint your eyes. The logs on the left are kind of, or the logs on the right hand are just kind of there for decoration on the slide. But this is Mike APT, Mike Advanced Persistent Threat. And I named it this because it's based on commands that I personally have used when pen testing GCP and Kubernetes environments. So I again broke it down in 4 steps. The plan's a little longer here, but four general steps of this plan. Is first to perform some general situational awareness with commands just available on the host OS. So things like that ID and who am I and several others, netstat and things like that. Then it attempts to retrieve Kubernetes tokens on the disk and access to GCP metadata API. And I mentioned that several times in the talk already, but if you aren't familiar with what that is, you're like, what the heck is that, Mike? It's essentially resource available in the cloud environment. It's similar to the AWS metadata API and the metadata API that's available in like almost every cloud environment. But that allows you to manipulate cloud resources from the workload. So it allows you to do that in the context of the current service account. So those types of elevations are things you want to be able to detect. So anyways, from there, the third part of this is that I'm bringing in my own tools. I don't like using the metadata API with curl. I like to use it with kubectl and gcloud. So those are pulled down from easier manipulation of those resources. And finally, the environment is thoroughly probed with those tools. So this plan, fortunately, generates a ton of noise, 57 Falco events and 2 GCP alerts. The alerts are triggered for permission denied, several permission denied in the same alert, and then listing secrets. So this is something that would definitely get my attention. And it did in real life because we busted an adversary in our infrastructure attempting literally some of these exact same techniques, like I think it was Friday. And I thought, did I accidentally run my emulation plan again? And it wasn't. It was a legit guy or gal, and we booted them, and it was a real nice validation of our rule sets taking place. So a couple notes on running your adversarial emulation plans. Your environment might be hardened, and that's good. You might be able to shut down some of these attacks. That's great. You should do that, but that's not the point. You might need to set up some temporary infrastructure just so you can emulate some of these attacks, so you understand if your detection rules are working properly. So I'm not saying poke holes in your infrastructure. I am saying, please make sure that your rule sets are doing what you need to do. And don't focus on eliminating every single rule or every single event. The plan on the last slide generated 57 alerts, or I should say 57 events. There's some events it didn't capture, and that's okay, because I could clearly look at that and say, wow, there's a big problem going on. I should take a look. And that's the point. So in close, really quick, I just want to leave you off with this thought. Try social engineering your adversaries for fun. I'm sure most of you know what a canary is. And if you don't, canary is a fake piece of data designed to lure in an attacker and specifically designed to trigger detection rules. So some things that you want to try, I'm not going to give you specific things that I'm doing, but some things you want to try are fake environment variables, tempting IAM credentials that are hooked up to nothing but a detection rule, fake JWT and Kubernetes tokens, irresistible file names, and little fake references sprinkled throughout. So your adversaries are sneaky. You be sneakier. That is all.